Bismillahirrahmanirrahim. Assalamu alaikum, everyone. Misha, thank you for the wonderful introduction. So as Misha just mentioned, I'll be talking about a case study, a project that we did recently that involves real-time data ingestion in an event-based system. So I'll start with here's the outline of my presentation, my talk. I'll be talking about a little bit about data ingestion. Then I'll start deep dive into the problem statement that we had and how we solved this problem using largely cloud components from the Amazon. I guess I'm not used to this. Yeah, okay. So data ingestion, what is data ingestion? Data ingestion is transporting data from the source of the data into a place where you can process the data, typically called a data lake or data lake house. So data could be structured, unstructured, as my colleagues have earlier mentioned. And why we need to transport data? Why don't we just process where it exists? So there are various reasons for transporting data to a lake house where you want to process them. It could be that data needs some refinement before you can actually start processing the data. Or the location where data is present, you may not have frequent access to that location. And also, the most important reason is that processing data requires large computational power, which is typically not available where data is present. So you move data from one or different locations to a single centralized data lake house where you can process it. So ingestion is of largely two types. It can be batch data ingestion or real-time data ingestion. Batch ingestion is where you ingest data in large quantities in single go. So you can schedule some cron jobs that can run weekly or monthly, can be daily based on whatever the frequency you want to ingest data, and then you process it. Real-time is slightly different paradigm. Real-time is where you want to process data in the real time. Data is being generated. As it is generated, you want to ingest it into a system and start analyzing and start producing results. Real time, again, it can be divided into further two categories. One is event-based and second is streaming processing. So today, in today's talk, I'll be talking about an event-driven real-time data ingestion. So let me start with the problem statement. We have the customer is a call center that runs call center operations 24/7, and they want to improve the performance of the agents and also the increase the level of satisfaction of the customers. So for this, they want to analyze all the calls or the events happening in the call center and perform analytics in the real time so that any corrective measures or performance improvements can be applied in real time. So in the call center, what is the data that we're talking about? It's the data about the calls that the customers are making for sport or for whatever queries they have, and how well the agents are responding to those calls. So how soon the call was answered, how long it took the call, and what was the customer's feedback after the call. So the events that we are receiving are in terms of when the phone started ringing, when the agent started the call, and how long it took the call to complete. And in the last, there's an event telling about the customer's feedback about the call. So this is a very high level architecture of the system. I'll go give an overview of the system first, and then we'll deep dive into each of these components. So data is in the form of an event of a call. As I mentioned, the events can be starting, the phone started ringing, the customer picked the call, that's the second event. The call may be transferred to a different agent, or the call was ended. All those events. So events are coming in the form of API calls. So the first entry point in our system is that we have to deploy a web server to receive the events. For that, we're using Amazon's API gateway. Gateway comes in some built-in authentication mechanism that we perform at the gateway so that legitimate data can be ingested in the system. After that, we perform some data enrichment because events does not contain all the required information that is required for further processing. So we're using a custom lambda function to perform some data enrichment. It may involve a lookup into our pre-populated caches or database. From here, the events are sent to an event bridge. We're using an event bridge because we have to make certain decisions on the data. And based on those decisions, the data can be processed real time or can be stored for later processing. So for this, we're using Amazon's Kinesis Firehose data streams to further process the data, not in terms of data processing, in terms of making data ready to be stored in a data lake. And then finally, the data lands in the last step into S3 bucket that is used as a data lake. So let's understand what's in the event. Event contains the other key elements that is present in an event. It starts with the agent ID, the call center representative who's receiving the call, start date of the call, end date, event type, and call ID. And there's one key component that is missing in this event. That is in identification of the call center of the customer ID. So now let's start with the implementation. API Gateway. So what is API Gateway? API Gateway is Amazon's managed service that is used largely for the development of APIs. So you don't have to create your own web servers. It provides you the capability to design the API and perform various operations. It's a massively scalable component and it's also a very secure element. So we're using API's basic authentication mechanism, the gateway, to secure our events that are coming in. And also, once the API key is verified, we are also doing a verification on the JWT token that is received. For the verification of JWT token, we're using a custom Lambda function because it involves matching the signature of the token against a pre-shared certificate. Then these authorized requests, which are ready to be processed, are sent to a Lambda function for data enrichment. So data enrichment in the data ingestion pipeline is a process of filling in the missing information or the information that is required for further processing of the event. In our case, as I mentioned, the events that are coming in, they do not contain the customer information, which is required for further processing. So what we do is we look up this information in a pre-populated cache in our system, and then put in that information in the event and then send it further. So event can be, information can be present, can be missing. In both cases, we send the event to the next step. Next component is an event bridge. So this red component in the middle. So event bridge is again an Amazon's managed service. It's a serverless event bus. Again, you don't have to write in code for this. You just have to configure it on the Amazon cloud. It's a fully managed service. It has a lot of built-in integration. This is very important because you don't have to write code to send event to an event bridge if you're using Amazon services. And also you don't have to write a single piece of code if you're sending the event to Amazon's built-in destination or Amazon's internal services. Event bridge also has ability to filter events that we'll see in the next slide. And it ensures reliable delivery of the event to the destination. So this is just a high-level design of the event bridge. You can see from various different Amazon components, they provide native integration to the event bridge. You can send data directly to event bridge, and event bridge can then send this data to multiple destinations. Again, that capability is built into the Amazon event bridge. So we talked about filtering, how event bridge filters your data. Event bridge provides the capability to add rules. Rules are just regex patterns that you can create, and event bridge can match your incoming data to those regex patterns, and based on those patterns, it can then decide whatever rule you have written. In our case, since the event bus, it has to send event to a destination. So based on the rules, you are sending event to one bus or the other bus. In our case, as I mentioned, after data enrichment, it is still possible that the required information that we're looking for was not present in our system and data was not properly enriched. In that case, we're not discarding the event, but we're sending this event to a different stream called the postpone stream. And because eventually we'll get this data from the customer and then we'll be able to reprocess those events that were not processed earlier. So there's just one rule in our case to find the specific fields. Are they present in the data, in the event? Was this enriched or not? So if the data contains all the required elements, it will send to a different stream called the process stream in our case, and data will be further processed. So next component in our ingestion pipeline is kinesis data Firehose. This is these purple boxes. You can see we have two kinesis data Firehoses in our system. One is for the processing of the event, and second is to for the processing or for the next steps in the postpone streams. So kinesis data Firehose is again a fully managed Amazon service. You don't have to again write in a piece of code to use this service. It's near real time. It provides some internal bucketing that so the events that are coming in, it buckets them and then shifts to your data lake. Bucketing is, in worst case, it can take up to 60 seconds for the bucket to fill up, or you can specify in terms of size as well. Let's say 3 megabytes is probably the minimum amount of data. So if either of these criteria is met, data is sent to the next step. Kinesis has the capability to directly populate this data into any of your preferred data lake or data storage mechanisms in the Amazon, like Redshift, Amazon S3, Elasticsearch, and Splunk. So since it's a managed service, you don't have to worry about scaling, or if the flood of data comes in, what will you do? Amazon takes care of these things. So a few other qualities of data Firehose is that it supports many data formats. Data can coming in JSON, XML, Parquet, or see whatever format. It supports a bunch of popular formats. It can also perform conversions for use. So let's say data is coming in one format. Let's take example, data is coming in as XML, and you want to store it in JSON format. So Kinesis, in Kinesis Firehose, you can just configure it to transform your data or convert your data from one source, one format to a different format. Further, if you need to do some other transformation that is not built into the system, you can use a custom Lambda function to perform those transformation. In our case, I'll explain the next step of what we did. Additionally, you can also compress data for storage. You can use gzip or any other supported format to compress data. And pricing for this service is again as per usage. So if you deploy Confiz Firehose data stream, you do not get billing charged right away. The amount of data that passes through the stream that is cleared, and you're only billed for the actual usage of this service. So this is an overview of the Confiz Firehose. You can see it can take in, data directly from various Amazon services. They have built-in integrations. They can directly send data to Confiz Firehose stream. And Confiz Firehose stream, after doing its own like conversions or transformations, can write this data to a bunch of services directly. These are the destinations. All right. So in our case, as mentioned earlier, we have two of these streams because the data that is coming in is either enriched or not. Based on that, the destination is different. So one Confiz Firehose stream will send data to one destination. That was the limitation because it's not an event bridge. It's not deciding what to do based on the data. It can only transform the data and perform the next step. So that's why we had two streams in place. And the last thing is dynamic parsing. I'll explain with the data lake. I have to move closer to use. So last step is data lake. For data lake, there's this last components, these green ones. We're using Amazon S3. Again, S3 is a massively scalable and reliable data storage provided by Amazon. So we're using just S3 to dump the data. Again, this is an ingestion pipeline. So the objective was to get an event and store it in the data lake so that eventually processing system, whatever ETL jobs need to be run, that can get this data from the S3 data lake. So structured data lake was designed so that it can support partitioning, and the tools like Athena or Redshift can directly curate data from your S3 instead of moving them to a Redshift database. So that's about it. So we saw using Amazon's technologies, latest technologies, we built an entire ingestion pipeline for an even-built system with minimal to zero coding. The only coding part was we were using custom transformations, custom authentication mechanisms. Other than that, there was no coding required for integration between different components. There was no coding required for performing so many other functions. So entire pipelines was built using purely the Amazon Cloud's provided components. And on top of that, we use Amazon's Cloud Development Kit. It's a programming, it's a library for writing infra as a code. So it was super easy for us to try out different combinations, try out different components, and destroy the infra and rebuild the entire infra within a short span of time. So that's it. If you have any questions, I'll be happy to answer. All right, thank you very much.
Hello, Assalamualaikum. I am Fahad, data engineer from Sembus.ai. I have a question for you. You have mentioned kinesis. In the term of performance and latency, which you prefer, kinesis or Kafka, as kinesis has some limitations?
Yep. So for performance, Kafka may be faster in some cases, but again, you have to verify so many good pros and cons of different systems. Kafka on Amazon has certain limitations. So since we're on the Amazon cloud platform, unless you have very strong reasons, I would suggest not to go with the Kafka.
Thank you.
Welcome. Arjit, thank you so much.
Thank you, Numan.